Hello, everyone. My name is Masashi Yoshimura, and I'm a software engineer at NTT Software Innovation Center. And today, I will talk about the session title, Technology for Lifting Machine Code to High Performance LLVM IR. Linux has been around for many years, and a wide range of Linux applications have been developed. And by reusing these by using this, you can cut development costs and improve application stability and more. Today, Linux containers are used in many environments, but there's growing interest in the more secure Linux applications to WebAssembly or other environments can bring big benefits, but it's very challenging for example, CPU emulators like QEMU incur serious performance bottlenecks. And so I propose porting porting Linux applications to different environments by compilation. So against this background, I'd like to introduce elfconv. elfconv is a LT binary translator for Linux elf binary. And so, yes, so and elfconv LT converts Linux applications into executables for other environments, and in its current form, it can take an ARC64 Linux elf binary to translate to the WebAssembly or Linux elf x86 64 elf binary, and we'll work on and in the future we'll work on converting to Macro binary in the future. So and elfconv use a library for Remir. So and Remir is a library for lifting machine code to LLVM IR. And the figure below shows how elfconv works. It first converts Linux elf into LLVM bitcode, and then uses existing compilers to generate a native executable for the target environment. And so, as for the demo, and I'm sorry, so it is unfortunately not ready yet. However, we expect to make it available in the next few days. Next, I'll explain what kind of LLVM IR Remir generates, and then introduce a new optimization path that turns it into a higher performance LLVM IR. First, Remir translates each machine code into a single LLVM IR basic block. And as sample instructions for this demonstration, we'll use 3 ARM64 instructions, MOV, branch, and add instruction. Below, I'll explain how Remir translates each of these 3 instructions. And the compression looks like this. First, you can see that the 3 instructions are each turned into 3 basic blocks: MOV at 1 and B at 2 and add at 3. Almost every instruction operates on CPU registers, so Remir defines a state struct to represent them. As shown, state has, as shown, state has fields for general purpose registers, TPRs, and SIMD registers, and more. And for example, the first instruction, M of x to x1, becomes a load from state x1 and store to state x2. Yep. So, and for example, the third instruction at x4, x3, x3, x1 loads from state x1 and state x3 and store the result into state x4. This is how each machine code is expressed in LLVM IR. But the Remus LLVM IR has a performance drawback. As mentioned earlier, Remus turns Remus turns each machine code into the one basic block. So basic blocks are handled independently, and virtual registers are not propagated between basic blocks. So for the same register, access the CPU state, the data in global memory data multiple times by many load and store. So to work on this problem, elfconv has an optimization path that transforms Remus LLVM IR into a more efficient LLVM IR. For example, the left figure shows that x1 is accessed 4 times in its control flow, and the right figure shows the converted LLVM IR by the improvement. Instead of touching the CPU state for the last 3 access, we propagate the x1's value between basic blocks by LLVM IR fine node. And so while this example is very simple, but real code has many loops or branches. So the algorithm is very complex. Okay, so and LLVM has passes, okay, like mTranche and SROA, but those only apply to local variable allocators and can't handle global data such as CPU state. Therefore, our new path treats global data as virtual registers whenever possible. Okay, so this is a benchmark test, and so this benchmark test shows that elfconv enables the creation of binaries that perform well in practice. But I'm sorry, time is low. Sorry. Okay. So this is the future work. I have many programs about the first is the long compile time, and the second is implement more Linux system calls for the target environment, and the third is enhancing x64 and x86-64 machine code conversion. And we are looking for the contributors, so any issues or peers are welcome. Thank you.